Hello guys! Welcome sa ating z-knowledgeTV.
Okay, so in this video, atin naman pag-aaralan yung isa pang topic under the data management or tinatawag natin na statistics. So, atin na pag-aaralan nung una yung introduction to data management, measures of central tendency, measures of dispersion, measures of relative position, and now we will discuss about the probabilities and normal distributions. Okay?
So, lahat ng ito ay pag-aaralan natin dito sa ating tutorial. Pero, before tayo mag-start, don't forget to like this video and click the subscribe button para ma-notify kayo sa mga next videos. So, let's get started.
Okay, so let's proceed sa ating lesson 5 or yung tinatawag natin na probabilities and normal distributions. Okay, so let's define first what is normal distribution. So, normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. So it is a continuous probability distribution that describes data that clusters around the mean. Data can be distributed or spread out in different ways. So it can be spread out more on the left. So parang tulad nito. So pansin natin na more of the data was spread out on the left. The other one is it can be spread out more on the right. So parang ganito. Okay? So, kita natin na yung mga data natin is more on the right. And pwede rin naman na it can be all jumbled up. So, ganito. So, parang hindi natin ma-determine kung nasaan yung mga data natin, yung mga malalaking data natin. Okay? Also, the graph of the associated probability density function is bell-shaped with a peak at the mean and is known as the Gaussian function or bell curve. So, for the normal curve, it was developed mathematically in 733 by Abraham de Moivre noong 1667 to 1754 as an approximation to the binomial distribution, which is ito yung na-discuss natin sa ating last video. Okay, under the measures of relative position. Okay, so his paper was not discovered until 1924 by Carl Pearson noong 1857 to 1936. So, Pierre Simon Laplace noong 1749 to 1827 used the normal curve in 1783 to describe the distribution of errors. Subsequently, Carl Friedrich Gauss noong 1777 to 1855 used the normal curve to analyze astronomical data in 1809. The normal curve is often called the Gaussian distribution. So, ito yung itsura ng ating normal curve o itatawag natin na bell curve. Okay, so bakit siya tinawag na bell curve? Kasi tsura siyang bell. Okay? So next, a normal distribution is a continuous, symmetric, bell-shaped distribution of a variable. The known characteristics of the normal curve make it possible to estimate the probability of occurrence of any value of a normally distributed variable. The properties of the normal distribution are as follows. So the first one is the distribution is bell-shaped. So ito yung natakal natin kanina. So the mean, median, and mode are equal and are located at the center of the distribution. Okay? So dapat pare-parehas sila at nasa center yung kanilang location. So the normal distribution is unimodal kasi nga isa lang dapat ang mode natin. At yung mode na yun ay equal sa mean at median. Next, the normal distribution curve is symmetric about the mean. The normal distribution is continuous. So, ito yung ibig sabihin ng ating symmetric about the mean. So, meaning, pag hinati mo doon yun sa gitna, so 50-50 dapat yung kanilang distribution. Okay, next. The normal curve is asymptotic. So, meaning, pag sabi asymptotic, it never touches the x-axis. So, kahit gaano kalapit, hindi sila magkaka-touch. Okay? So, the total area under the normal distribution curve is 1 or 100%. So, ito naman yung ibig sabihin nun. So, papansin natin na yung asymptotic tail is almost closer to x-axis. Pero, never silang magta-touch. Okay? Next, the standard normal distribution has a mean of 0 and a standard deviation of 1. The area under the normal distribution corresponds to a probability. The normal curve has the mean of 0 located at the center and the data are spread to a maximum of 4 standard deviations on both sides. And the last one is the area under the part of a normal curve that lies within 1 standard deviation of the mean is 68.2%. Within 2 standard deviations is about 95.4%, and within 3 standard deviation is about 99.7%. Okay? So, ito yun. Okay, so ang pinaka-center natin is yung ating uh, mean, median, or mode. Okay? Then, meron tayong first sigma. Okay, so plus minus 1 sigma yan, na meron tayong 68.2%. At meron tayong plus minus 2 sigma na mayroong 95.4%. At plus minus 3 sigma na may 99.7%. Okay, so take note na the standard deviation controls the spread of the distribution. The curve is taller when the standard deviation is smaller and flatter, and wider when the standard deviation is larger. Okay, so meaning lang ng standard deviation natin, so nakadepende yan sa spread ng ating distribution. Okay, so next, empirical rule. So also referred to as the 3 sigma rule or 68, 95, 99.7 rule is a statistical rule which states that for a normal distribution, almost all observed data will fall within 3 standard deviations denoted by sigma of the mean or average denoted by mu for the population ng mean and x bar for the population ng ating sample. Next, in a particular, the empirical rule predicts that 68% of observations falls within the first standard deviation or sa formula natin na mean plus or minus sigma. Next, 95% within the first 2 standard deviations or mean plus minus 2 sigma. And last, 99.7% within the first 3 standard deviations, mean plus minus 3 sigma. Okay, so ganito siya. So meron tayong normal curve at ito yung mga standard deviation natin. Yung gitna niya, siya yung mean. And then yung sa ating first sigma, so meron tayong 68%. Sa second sigma, meron tayong 95%. And sa third sigma, meron tayong 99.7%. Next. Okay, so dako tayo sa ating example 1. So let's assume a population of animals in a zoo is known to be normally distributed. Each animal lives to be 13.1 years old on average, and the standard deviation of the lifespan is 1.5 years. So what is the probability that an animal will live longer than 14.6 years? Okay, so knowing that the distribution's mean is 13.1 years old, okay, nasa given yan. Then the following age ranges occur for each standard deviation. Okay, so para sa ating first standard deviation, so may tayong formula na mean plus minus sigma. Okay, so meaning naka-range yan kasi meron tayong plus minus. So, kunin natin ang mean plus sigma. So, ayun yung magiging upper limit natin. Okay? Then, yung mean minus sigma, siya yung magiging lower limit natin. Kaya magiging range natin is 13.1 yung ating mean minus 1.5 yung ating standard deviation to 13.1, again, yung ating mean plus 1.5 yung ating standard deviation. So, solve lang natin yan. So, magiging 11.6 to 14.6. So, ito na yung range natin. Okay? Ito yung range natin para sa first standard deviation. Next, so para sa 2 standard deviation, okay, ang formula naman natin is mean plus or minus 2 sigma. So, dodoble lang natin yung ating sigma. So, same pa rin. Magiging 13.1 minus 2 times 1.5 up to 13.1 plus 2 times 1.5. So, pag kinalculate natin yan, makakuha tayo ng range na 10.1 to 16.1 para kay 2 standard deviations. Next. So, para sa 3 standard deviations, so, i-multiply lang natin yung sigma natin sa 3. So, same pa rin mangyari. So, magiging 13.1 minus 3 times 1.5 to 13.1 plus 3 times 1.5. So, calculate lang natin, magiging 8.6 to 17.6. So, ayun yung magiging range natin para sa third standard deviation natin. So, the empirical rule shows that 68% of the distribution lies within one standard deviation, in this case from 11.6 to 14.6 years. Kasi sabi dito, what is the probability that an animal will live longer than 14.6? So, mas mahaba sa 14.6. So, meaning, since na yung 14.6 natin dito kay 68% is within ng range natin na 11.6 to 14.6, so, ang kailangan natin hanapin is yung above 14.6, which is itong second standard deviation at yung third standard deviation papasok. Pero, since na yung 68% natin is nandito sa range na to, so ilan na lang ang natira sa 100%. So, makuha natin yon na 100% minus 68%, so makakuha tayo ng 32%. Kaya naman, yung 32% na yon, okay, is naglalay outside ng range ng 11.6 to 14.6. Okay? So, ayun na yung kabilaan side, di ba? Okay. Ngayon, yung 32% na yon, so hati natin siya sa dalawa kasi kabilaan yung distribution natin. Okay? Equally distributed sila, di ba? So, magiging 16% na lang. Okay? 16, 16, kabilaan. Okay? So, meaning, half lies above 14.6 and half lies below 11.6. So, the probability of the animal living for more than 14.6 is 16%, calculated as 32% divided by 2. So, yun yung nasa taas ng distribution natin. Okay? So, kung i-drawing natin yan, so parang ganito ang mangyari. So, meron tayong curve. Okay? Let's say this is a normal distribution curve. Okay? So, ito yung ating first sigma na meron tayong 68%. Okay, meron tayong 68%. Okay? Eh, di ba ang kabuuan ng ating distribution is 100%. So, therefore, ilang percent yung natitira natin? Itong nasa labas. So, meron tayong kabuuan na 32%. Okay? So, para ma-distribute natin yung 32% kabilaan, i-divide natin yung sa 2. So, mangyari, mula dito sa end, okay, mula dito sa end, hanggang dito, sa ating unang part, so, ayun yung 16%. And then, mula dito sa last part din, sa end. So, hanggang doon. So, ito yung ating another 16%. Yan. So, in total, 100% sila. Okay? So, itong 68%, nandito yung, let's say, ito yung 11.6. Tapos, nandito yung 14.6. Ayan. Okay? So, meaning, yung more than 14.6 years is 16% yung probability. Okay? So, ito yun. Ayan. Ayan. Okay? Okay, so dapat tayo ngayon sa ating next topic, which is Chebyshevs Theorem. So for any numerical data set, at least 3/4 of the data lie within two standard deviations of the mean, that is in the interval within endpoints, mean plus minus 2 sigma for samples, and with endpoints na mean plus or minus 2 sigma for populations. Okay? So at least 8/9 of the data lie within 3 standard deviations of the mean, that is in the interval within endpoints ng mean plus or minus 3s for samples, and with endpoints mu plus or minus 3 sigma for populations. At least 1 minus 1 over k squared of the data lie within k standard deviations of the mean, that is in the interval with endpoints x bar plus or minus ks for samples, and with endpoints mu plus or minus k sigma for populations, where k is any positive whole number that is greater than 1. Okay, so take note, greater than 1. Kasi pag inequal nyo yan sa 1, so kung titignan sa formula, 1 minus 1, then yung k magiging 1. So 1 squared is 1, 1 divided by 1 is 1, then 1 minus 1 is 0. So, hindi pwedeng ganun. Okay? So, kaya naman, dapat greater than 1 yung k natin. So, according to this theorem, at least 1 minus 1 over k squared of the measurements will fall within this range. Okay? So, mean minus k times sigma hanggang sa mean plus k times sigma. So, yun yung magiging range natin. Okay? So, let's take a look in this plots. So, ganito yung itsura sa Chebyshevs Theorem natin. Na kung saan yung mean natin still nasa center. Okay? So, pero hindi pa rin niya tinamaan yung pinaka-center ng ating plots. Kasi itong plots natin is bimodal. Okay, so ito yung ating 2 sigma na may range tayo na at least 75% or at least 3/4. And then ito yung ating 3 sigma na may range na at least 88.89% or 8/9%. Okay? So, kaya naman na it is important to pay careful attention to the words at least at the beginning of each of the 3 parts. So the theorem gives the minimum proportion of the data which must lie within a given number of standard deviations of the mean. So kaya naman na dapat in every answer, so dapat lagi tayo may nakalagay na at least sa umpisa. Kasi yung nagbibigay sa atin ng indication na minimum proportion yung data natin. Okay, so the true proportions found within the indicated regions could be greater than what the theorem guarantees. Okay, so next. So, punta tayo sa ating example 2. So, the average lifespan of Filipinos is 73.5 and the standard deviation equal to 5.5. So, if k is equal to 2, what will be the range of the lifespan fall? So, ito yung ating equation o formula para sa range. Okay? So, meron tayong mean minus k times sigma. Then, 2 mean plus k times sigma. Okay? So, yung mean natin is 73.5. Then, yung sigma natin is 5.5. Then, yung k natin is 2. So, ang magiging equation natin is 73.5 minus 2 times 5.5 hanggang sa 73.5 plus 2 times 5.5. Okay, so makakuha tayo ng range na 62.5 to 84.5. So, nandito daw yung age ng mga Filipinos. Nasa range na yan. Okay, so kung natin yan yung ating percentage ng ating lifespan using this formula. So, 1 minus 1 over k squared. Kung saan yung k natin is 2. So, magiging 1 minus 1 over 2 squared. And yung 2 squared is 4. Then, 1 over 4 is 0.25 or 1/4. Then, 1 minus 1/4 is 0.75 or 75%. So, therefore, thus, at least 75% of the lifespan are between 62.5 and 84.5. Okay, so yun lang. So, doon na nagtatapos yung ating discussion para sa probabilities and normal distribution. So, maraming salamat.